Well, good afternoon, everybody, and welcome to our online workshop series, Managing Legionella Risks for Buildings, your guide for a safe reopening and operations. My name is Troy Raszka, Vice President of Marketing for Pure Air Control Services, and with me today I have special guest, Dr. Rajiv Sahay, who is the Director of Environmental Diagnostics Laboratory here at Pure Air Controls. Welcome, Doc.
Good afternoon to everyone, and good afternoon to you, Troy.
Yes, so today we're here to talk about Legionella, and that has been an ongoing concern for buildings for many years now, but maybe it's an especially heightened concern now that we're in the middle of a pandemic and many office buildings and schools and other buildings are set to reopen as perhaps the pandemic eases due to vaccinations and other factors. So today, we're going to jump right in, and this is our agenda. I know it looks like a lot, and some of you might already know some of this, but I feel like it's a good time for a refresher and to be thinking about what kind of planning you need to do to be able to test your water systems in your buildings. So today we're going to look at, why do we need to be concerned in these current times? Of course, a brief overview of what Legionella is and some of the current events surrounding it. And then we're going to look at some of the reopening guidance, specifically covering ASHRAE 188, at least as it relates to Legionella testing and surveillance in buildings. And then what are the influential factors that play into the proliferation of this bacteria and other pathogens in and around buildings, how to diagnose or test for it, which will include sample collection, what the laboratory does behind the scenes for their testing and reporting, and then a brief overview of some control measures that would be taken should you find Legionella in your facility. And then, of course, we'll have time for questions and answers at the end. So I do ask that you hold all of your questions and answers till the end. But if you have to leave a little bit early, go ahead and post them in the question tray, and we'll certainly get back to you via email with those answers. Of course, we also want to check our handout tray, because I know we get asked a lot of times, but the slide deck, today's slide deck is in there for download, as well as our Legionella handbook. So we have the Legionella handbook that's available for download, and a couple other useful flats of information. So with that said, let's get right into it. So obviously it's been a heck of a year with COVID-19 and the pandemic and the paradigm shift in building operations and how we as workers, students, go about our business inside of the buildings, or maybe don't anymore because those buildings have been shut down. And so as we're talking today about Legionella, why should we be concerned about this bacteria? Obviously, a lot of focus, and rightly so, is being placed on SARS-CoV-2. But how does Legionella play into this whole pandemic, and certainly inside of a building? So, first and foremost, Legionnaire's disease, or Legionella bacteria, I should say, is a significant risk to human health in three main ways. So one, we know that it causes what's called Pontiac fever, or mild febrile illness. And then, of course, a lot of you, most of you probably have heard of Legionnaire's disease, which is a very serious form of pneumonia that can be lethal to humans if not treated correctly or caught soon enough. And then, of course, it can cause other extrapulmonary syndromes that can affect the way that we breathe and, again, human health. Of course, the other side of the coin with our concern today is that because of the pandemic, many buildings have been closed or been put under minimal operations. And this, of course, can lead to deferred maintenance, not only because a lot of building owners and facility managers are focusing so heavily on COVID-19 prevention that they're looking at new technologies new traffic flow, heightened disinfection of the occupiable space, so they might not be looking at their building water system as closely, where this bacteria can proliferate. And then, of course, because of these minimal operations, closures, deferred maintenance, favorable environmental conditions are starting to exist for this bacteria to spread within these buildings. So, Dr. Sahay, why don't you take a couple minutes and explain to us, certainly the folks that might not really know what Legionella is, explain to them exactly what this bacteria is.
Well, this is a very primitive question, and I guess many of you already know the answer, but I'm just going to give some information on that. As you know, the bacteria is nothing but it's a microorganism, meaning you cannot see this organism with your naked eye. So you have to have an added eye, meaning you have to have a microscope to see that. Well, the Legionella is a bacteria which is basically considered as environmental bacteria because it proliferate most of the time in the environment, but of course it has a clinical significance because it can also create some illnesses or diseases in the human being or infections, so do you speak. Now, it is naturally occurring because it is not like a man-made bacteria or it is not something extraordinary created in the laboratory, but it is just naturally occurring. Those who understand a little bit about the bacteria, but most of the bacteria has divided into bigger group, possibly three, is based on a staining type called as Gram. That was a gentleman who decided to go with this kind of staining technique. So on that staining technique, if this bacteria is stained, it stand as a Gram negative because it doesn't pick up the stain. And as you can see in this slide right here, this is the shape of the bacteria. It's just like little thread or little pin like a structure, longitudinal rod shaped structure. But sometimes it is like coco bacillus, meaning it has a round and a combination of rod. So round and rod, so that become coccobacillus. Sometimes several cells held together to appear like a thread, that what we call filamentous. So it can also appear in the filamentous form as well. Well, this bacteria is very important because, as I said you, that it has a clinical relevance, meaning that it is pathogenic in nature. Many times it is being noticed as a nosocomial, meaning that it can be acquired from the hospital. If you get admitted in the hospital or you're visiting the hospital to get taken care of you for some other illnesses, maybe you can get infected if there is some Legionella around. So pathogenic, nosocomial, that make it very important, and that's why we are discussing it, because you can acquire this infection if the bacteria is around you, meaning in the environment where you are working or you are living. If that makes sense.
A very good description, Dr. Sahay, and it is especially important to buildings, and especially buildings where people are occupied, and we're going to get into sort of the criteria of those type of occupations in the building. But as you can see, just in this last month, there's been a cluster of Legionella discovered in Clark County, New Jersey, which is just on the other side of Long Island. And that has prompted the New Jersey Department of Health to start to investigate this cluster, as well as some of the lawmakers in the area looking at new regulations for cooling towers. That is, of course, part of the HVAC system and water system in a building. And, or I'm sorry, Union County in New Jersey. And then there's also been a new Legionnaire's disease case discovered in Portland at the Rosemont Court, which is a assisted living facility, apartment complex, senior living facility. So Legionella and Legionnaire's disease is not going away because of the pandemic. It still exists, and you could do a quick Google search, either relevant to current time or even in the past year, and see all of the number of various clusters and outbreaks that are still occurring because of this bacteria. So with that said, ASHRAE, which is one of the leading governing bodies for HVAC systems, refrigeration, heating, and cooling in the United States, as you may have known, has issued reopening guidance for buildings. And we've covered this in some of our past workshops. and they have a very robust website. I've watched it almost in real time develop and be updated and revised as new information is coming in. But the information that we're going to deal with Legionella and with legionellosis, that's a tough one to say, really goes back to their guidance 188, or ASHRAE ANSI Standard 188. And in this reopening guidance, they've listed 8 pillars, which we've covered in previous webinars, but one of those 8 pillars is relevant to the building water system and water system precautions. And so what they tell you there is to go and refer to their previously written standard, updated in 2018, and their guideline 12, which can help minimize the risk of waterborne pathogens such as Legionella. So as far as building reopening and guidance, this is one of our roadmaps to ensure the safety and minimize risks. So the main scope of ANSI ASHRAE 188 is just that, to minimize Legionellosis risk management requirements for the design, construction, commissioning, operation, there's a key word, maintenance, another key word, repair, replacement, and expansion of new and existing buildings and their associated water system and components. So again, like the HVAC system, drain pans, evaporator coils, cooling towers. And then, of course, this is applied to human-occupied, commercial, institutional, multi-unit residential, and industrial buildings. So they make sure to note here that it doesn't really include single-family residential buildings, but we're looking at more of the commercial side or multiple occupancy type of buildings. So that's sort of the main scope, is risk management to large occupied buildings. And so this is part of the cover of this documentation that sort of shows you the recent revisions. And really, for the purposes of what we're talking about today, because we don't want to get too far down the rabbit hole of actual building water systems and that, but we're going to look at 4 areas out of these 3 main sections. And that's section 4, compliance, section 5, the building survey, and then section 6, general requirements as it relates to a water management program. Because this is where the biosurveillance is going to take place to make sure that you're managing those risks for Legionella. So in section 4, I mean, it very just simply states that they're asking you to look at the determination and the associated building survey, which we're going to talk about in section 5, and they're telling you that it should be documented and it should be either physically or electronically on site for review by whoever maybe your governing authority or jurisdiction is. And so basically what they're recommending is that you keep detailed documentation of what you're doing to manage this water system and the risks around the Legionella bacteria and of course other waterborne pathogens. So I know we're going to move through some of this very quickly. You can always refer back to this documentation on the ASHRAE website. It's a very detailed document, and I'm sure most of your facility managers and engineers would be pretty familiar with this by now already. So we're going to skip ahead over here to section 5, which talks about conducting a building survey or knowing your facility. And so 2 of the main factors that they want you to look at when thinking of your building survey is the type of water system that your building has, and then what are the factors that might contribute to Legionellosis. And so they want you to know the type of water system, open, closed circuit cooling towers or evaporator condensers, any kind of water features such as whirlpools or spas, and of course all of their locations. And again, fountains, misters, atomizers, any kind of air washers, humidifiers, non-potable water systems, or any kind of device that will release water aerosols in the building or around the building site, because these are all kinds of delivery mechanisms or vectors for Legionella to be respirated or breathed in by the humans that are occupying or around the space. And then, of course, again, as we stated in their sort of scope for ASHRAE 188, they're looking at multiple housing, 10 stories or more, maybe a healthcare facility with 24-hour patient stay, or assisted living facilities or skilled nursing facilities where there's patients 24 hours, and then how the building is being utilized overall. So these are sort of the main factors for 188 that you want to be aware of when you're looking at being compliant with this standard. And so when we talk about water management, and they go into great detail in section 6, and so we're going to give you a couple of things just to think about here and sort of highlight where you want to put testing as part of your routine maintenance or surveillance. And so a water management program team, these are all of the elements or the people or skills that are involved with running a water management program team. So you're going to need to have the ability to oversee the program, have knowledge of those water systems, the ability to identify control locations and limits, the ability to identify and take corrective actions, the ability to monitor and document program performance, the ability to confirm the program performance, and the ability to communicate regularly to the other stakeholders in the building about the program. So what are you doing and with this water program? So the ability to identify the locations and control limits, the ability to monitor and document the program performance, both are key areas of your water management program team that is going to be responsible for taking water samples, sending them to the laboratory to be able to test for the presence or absence of the Legionella bacteria. And then when we look at the development of a water management program as a whole, right, the first step is to establish that program team. And then you're going to have to document or describe the water systems using text and flow diagrams. And then this is important, identify areas where Legionella could grow and spread. And then decide where control measures should be applied, how to monitor them, establish ways to intervene when control limits are not met, and then make sure the program is running as designed as it effective. And so it all comes down to being able to document and communicate all of your activities. And this, as you're going to come to find out, a certain reassuring part of this is going to be have frequent laboratory testing and reporting to provide or supplement that documentation of this program. And of course, this particular flow chart here was sourced from the document CDC developing a water management program to reduce Legionella growth and spread of buildings. So this is coming directly from the CDC, basically saying you need to have a team, you need to have a program, you need to test, you need to document. And so very important. So, once we establish the team and the program and these sites and what might contribute to it, we look at what are the influential factors that could create a situation where Legionella grows and proliferates. And Dr. Sahay, why don't you kind of run us through what these influential factors are?
Well, that's a very good explanation. People need to understand that since Legionella is a microbe, it's a living thing. So every living thing has certain requirement in order to proliferate or in order to get their life going. So Legionella is one of the microbes, so it doesn't require tons of food and anything, but it required some nutrition as well as some condition. What we call is a favorable condition if it is supporting the growth of Legionella, in other words. So the first supporting factor is the temperature. Legionella kind of tolerate high temperature. As you can see here, the temperature in degrees Celsius, I know many of you understand in the Fahrenheit, but just for an IS unit, International Standard Unit, is 35 degrees Celsius to 42 degrees Celsius. That's kind of on an average. if you are thinking about in terms of Fahrenheit, let's say somewhere like 75 to 75 to 80 degree Fahrenheit or something like that is one of the temperature which is very supportive to the Legionella growth. The other important factor which we need to understand is that for get the life growing, you have to have certain kind of infestation. You can call it like, the multiplication or replication, meaning that you have to have inoculum. So unless and until you have inoculum or you have the seed, let's put in a very vague word or very like, general terminology. If you do not have a seed, you cannot grow the plant. Likewise, if you do not have a spore or you do not have an inoculum, you cannot grow the bacteria. So this is the problem, because right now everything is not well maintained in most of the workplace. I'm not commenting upon like, it is not maintained at all, but the maintenance is being deferred, and the reason is obvious because we have less workforce at this time. So in the plumbing system, your HVAC, which is heating, ventilation, air conditioning system, and the water mister, etc., that you see the water fountain and things like that for the decoration or beautification of the property, those are not well maintained. So the Legionella is going to not keep growing, rather they are going to harvard and they are going to hibernate and wait for the favorable condition. So don't think that your building is closed and the Legionella is going to die by itself. It's not going to die, rather it proliferate. That's the technical word, but I want to simplify in English that they hide themselves and they are keep hiding until they get the favorable condition to just come back. So that is the one thing which I want to pay attention on that. So be very cognizant of that, the deferred maintenance. So try to like, back up your schedule to maintaining like, water flow, flushing, etc. And then the third one is a very important one, is the pH factor. pH factor is basically, pH is a scale which tells you that how basic condition or how acidic condition you are in. So the Legionella require a particular type of pH in order to grow. So unless and until you are going to disturb that pH, then that pH is going to be the supportive to it. And then the nutrition. Nutrition is that as I said you, that it doesn't require very big food, but some basic element as a nutrition, and that is protein-based nutrition. Sometimes you will be surprised to know that even though you do not have like a lot of chemical, etc., but if you have some protozoan cell in the back in your plumbing system, in form of like, the biological residual or whatever, like protozoa, I just given you an example, that can supply the nutrition. For that matter, several other bacteria is the nutrition of that bacteria. So the life is very complicated. So these kind of nutrition they can obviously get in the plumbing system or water system, natural or potable, non-potable water system. So the nutrition is the another factor. The biofilm, I'm pretty sure I'm not going to speak a lot on this biofilm stuff. It will take me a lot of time, but just to sake of understanding that if you are in a stagnant mode, then there is a lot of spores and other biologicals which are going to accumulate in your flushing or your point of use and etc. And many a time in practical sense you see some kind of gooey material, in lack of better word, like a mucilaginous material, viscous material. You see that is saccharides kind of, or chemically those are like saccharide based material that can harbor these spores, and the spores are kind of hiding there, like minimizing their requirement so that they can get by for that hardship. Like we have not a lot of like money, then we try to get by with the basic food. We are not like having the big preferential food like a steak from a big steak house or something. Rather we can just like try to get something which we can get by and don't go hungry. Likewise, this biofilm is like kind of cohesion or adherence of lot of different kind of biologicals, and that is like one of the place where Legionella can also hide themselves. And then the chlorine residue is one of the thing, like if you have a little chlorine residual, then that is like not a favorable condition. So the chlorine is anti Legionella. So if you have a chlorine like residual, then you are not going to have a lot of Legionella there. So they try to avoid the chlorination or the bleaching. And several other factors such as regular or nuisance dust and debris, etc., that has a little bit of nutrition, that is the supportive factor of Legionella. So these are the overall supportive factor of Legionella that can get the Legionella growing or let the Legionella flourishing. So that what we call influential factor in terms of microbiology. Does that make sense?
No, it makes perfect sense, Dr. Sahay. And I think that, the higher temperatures, deferred maintenance, pH level, and then of course, obviously, as you said, it's a living organism. So it has to have something, some kind of nutrition to be able to reproduce and move on. So, now that we sort of established what the factors are that make the conditions favorable for Legionella to exist inside of these building water systems, we have to figure out how to diagnose, where it is, how much of it there is. And so, on this slide, and Dr. Sahay worked with me to develop this roadmap, as it were, or cycle, maybe even is a better word to describe it, on how to diagnose for Legionella in a building water system. So why don't you sort of walk us through this process, Dr. Sahay?
Sure. This is very important and crucial step, meaning it is very, very essential in order to maintain the Legionella or having a Legionella water plant to avoid any kind of damage due to that. So what we need to do first, we need to make sure that we can decide a frequency. How frequent are we going to take care of our investigation to make sure that you don't have Legionella? And I wish everybody should not have Legionella, because that's not a good thing to have. So someone can, it depends upon your requirement or your facility, how big it is, how many people are working there, whether you have a previous episode of Legionella or not, etc. These are the conditions. Based on that condition, you decide the frequency. It can be quarterly, it can be half yearly, or at a minimal, it can be annually or at least once in a year. That kind of cycle you need to determine. So first determine the frequency, and like Troy was telling earlier, that you have a team to manage your sort of water system, but at the same time it is very important that you can collect some sample in order to find out that whether there is a Legionella or not. Because if you have all kind of good system and everything, but if you are not testing, who knows what is in that water. So make yourself familiarized by doing some testing. It's something very simple, and very simple few steps can buy you a lot of peace or a lot of uh, good management or good practices, in other words, to make sure that you are protected. So the sample collection is obviously one of the crucial steps, just in order to find out whether you have Legionella or not. Then of course, if you collect the sample, you are going to send it to some laboratory to find out whether the Legionella is there or not. Number one question, that if it is there, how much it is, meaning you have to interpret the result, whether it is significant, non-significant, one or two colony you can get by with it, or what is the fit. So there is a lot of interpretation can be made based on the laboratory findings, which comes upon testing of the collected sample. And now of course, if you have a problem, God forbid, nobody has any kind of problem, but if you have a problem, be realistic, be practical. So what we are going to do, if there is a problem, there is a solution. So how we are going to make that solution? We are going to do some control measure. It's as simple as that. And that what my cycle of this chart is showing you, that you collect the sample and then you do the laboratory testing, result interpretation. If result is unsatisfactory, meaning you get Legionella reported, you have to again the sample collection, you have to go again that sub cycle until you find out that the sample collection and testing is satisfactory, and then you can accept it. Whether it is acceptable or not, again, that is another thing, that how much is acceptable, that is some other presentation we can talk on that. But just say for this time, like, if it is acceptable, then record it, because one can work in one company, they can move out some other company, but record doesn't go anywhere. So if you are a building maintenance in charge or someone, if you record that, jot it down, then your other people can just find out that what was the position. So you can keep doing this thing on the frequency what you chose, or what you say you do, what you have to say. So based on that principle, you can maintain that, and that how you diagnose the Legionella in the building.
No, that's
I think,
exactly correct, Doc, because if the resultant interpretation is unsatisfactory, then it would be up to the building manager and engineers to be able to take those control measures, and then once those have been executed, to go back and start the sample process over again until you get that satisfactory result. And then again, speaking to ASHRAE 188, recording those results with the report and having that documentation, and then having the frequency that you're going to be testing for this, as Dr. Sahay said, maybe it's once a year after you do the initial test and water flushing or control measure, maybe it's once a quarter. It depends on the type of facility or building that you're in, and that will help determine that frequency. But both of those, the documentation and the frequency, are all part of that water management program that both ASHRAE and the CDC recommends. So this diagnosis or this laboratory testing and analysis is key to those two areas for risk management and health and safety within your building. So as Dr. Sahay was talking about, when we talk about collecting samples, and now we're going to sort of get into some of the very detailed ways that we can do this as part of the testing method, and that is we're going to look at how to collect the samples. And so as part of this program we were talking about, you have to identify the sampling site and source. So if you have a water management program, you're going to know exactly where you need to pull those samples from. And then again, depending on that site or source, there's going to be a specific type of sample that you're going to need to collect. And then based on those two criteria, and then Dr. Sahay is going to go into more detail here in a second, but based on those two criteria, that will help you determine what volume of the sample is going to be needed so that you can have an accurate test and analysis provided. So we're going to go right into this process of sample collection. And I'm not an industrial hygienist or microbiologist, so I'm going to let Dr. Sahay take the lead here. But Doc, why don't you walk us through some of these sample collection methods?
Correct. The very first question, or very frequent question I get all day long, is that how many samples need to be collected and where I should be collecting the sample. And that's a very valid question. Answer to that we have a very good guidance on that, how to select the sample collection area or site, but making everybody a little aware that you need to first identify that what are the point of use in your water system, so to speak. So of course you can not test every single outlet in your water system in a building for the Legionella, but the good exercise would be at least you consider 1/3 of the point of use, POU, randomly to collect the sample. Then if you have different storage tank where the water is being stored, some party buy the water from the third party, the water supplying company, or you have a well on your property. So if you have a water storage tank, then again you have to be at least one sample from that water storage is obvious, because all the water which is being supplied in your facility is coming from there. So you can take sample from there. The cooling tower, if you have a cooling tower in your property, then at least you can select randomly half of the cooling tower. At least it is better to test all the cooling tower, but if you cannot afford to do all, at least you do half of them, and collect the water from, like, the compensating water and things like that, which in a minute I will be telling you how to collect the water. And then if you have a well on the property, then it is also a good idea to go do at least one sample from there. And then I highly encourage, if the water is coming from the third party source, then where the water entering in the building, at that point, if you collect one sample at least, you will have very good understanding that what kind of water you are getting, whether it is Legionella free or some Legionella problem to begin with. And then the last one, many times people ask me that what else we can do. Well, lot of property has sprinklers and stuff, so you can also try to get some sample from the sprinkler system, the heater, if you have a heater or a central hot tub, or the unit where you can, like, do the water heating before it get distributed, so you can collect the sample. Well, that I have taken a little side, like, note, so that you understand where to collect the sample. Now straight away go how to collect the sample. That is a second very frequently asked question in the laboratory. So let's go one by one. The portable water source, I'm pretty sure that many of you understand what a portable water source. So from the portable water source, you should be collecting ideally 1 liter of water. As you can see in this diagram, that you can just open the point of use, and then, like, maybe a 1 liter bottle or little big 1 liter container, which is should be clean or at least sterile, because there should not be pre-contaminated bottle or things like that. And then one very important thing I want to make sure that you understand, if your facility is recently treated with the chlorine, then you must mix this one. This is called as fixative or the stabilizer, and which is 0.5 ml per liter is 0.1 N solution of sodium thiosulfate. It's a mouthful of word, but if you are hiring any laboratory, request them, they can send you this fixative with the container. So you have to have that. Once you collect the water, which is 1 liter in volume, then tighten the container pretty good. And you can additionally take a measure that if it is screw bottle, that's really good, because you tighten the screw all the way, and then you can use a strip of parafilm wrap around, so there is no leakage during the or while the sample is in transit. And then fill the chain of custody. This is very, very important, and I want to make sure that you understand that the chain of custody is one of the crucial legal document, so that it can be traceable that who had hand on the sample, or who is going to analyze the sample, and when sample was collected. All these kind of information you can find on that. Now I'm going to tell you to collect the sample from the non-potable water, which is, I guess, is our next slide. Is the water source is just going to be different because it's a non-potable. Those who don't understand what a non-potable water system, the non-potable water is basically nothing but it's like a collection basin or some storage tank, reservoir, heat source like a chiller, etc. Those are the non-potable water. Okay, so in the non-potable water, again the technique is same. I beg your pardon, the spelling of liter is wrong there, but by using a aseptic technique, 1 liter of water is again collected from those sources in a sterile condition, and the same manner here you can draw the water, because sometimes the water is just not going to come. So if it is water, then avoid the stagnant at the bottom, like the debris or something will settle, avoid that. But you can just take, like, just remove the cap out of the container and then draw the water, and then afterward again seal the water properly, fill the chain of custody, and then that sample is ready for sending to the laboratory. Now the next source, or the water source, is such as pond, and except the whirlpool or tank or decorative fountain, etc. You can collect 100 to 300 ml of water. That is adequate to run a Legionella test. Again, you need to draw the water, just avoiding the the settled debris, etc. And then you can just make sure that all the sample, when you are doing the sample collection, one thing I warn you, that if you are doing by yourself, that's why I was not telling you, if you are hiring someone, that's fine, but if you try to do by yourself, then you must wear a PPE equipment. The PPE includes you have to have at least gloves, like see your hand is going in the water, and if water is contaminated of the Legionella, then it is going to transfer to you. So real quickly, the PPE can be as simple as that: a pair of gloves, goggles, and extra layer of clothing on your regular clothes. Then that can be just serve as a good PPE here. So make sure that you wear the PPE before you collect, or you attempt to collect by yourself. Again, if it is a whirlpool or big fountains or pond, etc., you can have 1 liter. But if you have a little less water, for an example, many time in the air conditioning drain fan, you are having a hard time to get 1 liter of water. In that kind of situation, you can collect 100 to 300 ml of water. That is adequate to run the test. And in a minute, I will be telling you that if you have a even lesser volume, how to handle those kind of situation. I will be telling you in a minute. And then again, the same process, I'm not repeating. If it is a bottle screw, that's a good one, but you have to tight this screw all the way, and then you have to make sure that you wrap with the parafilm and things like that. Fill the chain of custody, send it to laboratory. Make sure your transit period should be very fast. Like faster the sample come, better the result you will be getting, because if you have the sample sitting somewhere, that has an impact on the growth of bacteria. So result can lean in either way, like depending upon the condition when the sample is exposed after collecting. Now real quickly, I'm going to tell you the next slide, which is going to talk about how to collect the sample with a swab. That the swab sample collection is a little bit of tricky, but I'm going to tell you it's nothing that you cannot handle if you want to. That the swab sample are collected with obviously a swab, and that kind of environmental swab you can procure. This swab is a little bit flattened than the regular swab, and this is polypropylene material. That material is not typically cotton, because avoid the bacterial contamination, because in cotton there is easy the other bacteria can grow, but it's a polypropylene material swab. And then you moist the swab, not really load the swab with the water, but it's just the moist enough so that when you put this swab, you can go back and forth, or you can roll over, or you can just very gently scrub over on the surfaces such as aerators, faucets, shower head, water liner, jet of the decorative fountain, safety shower, etc., humidifier. As you can see there, it is going to be just rotated in this end, and that way you can collect the sample. Then you put the swab in the container where it comes from, and then of course you fill the chain of custody. Make sure that the swab container is tightly sealed. Again, label the swab, uniquely identify the swab container, and then fill the appropriate chain of custody, send it to the laboratory, and the laboratory will take care of that. Again, faster the sample, better the result. Your attempt should be transiting the sample to the laboratory, or either hand deliver or by mail, or however you want to, any kind of delivery mechanism. Make sure that the sample get delivered within 24 to 72 hours. Otherwise, we have to do some special precaution. Still, we can do the sampling, but we have to make sure that we do a special precaution to preserve the sanctity of the sample.
And
Now,
Dr. Sahay, isn't so like if you're dealing with a normal chain of custody, uh, that will actually sort of be a little bit of guidance in its own right, as far as to tell you how to label the container and the location it was taken from, the date, the technician taking the sample. Is that correct?
yes, at least in our laboratory, this is in practice, because our chain of custody with the EDLab chain of custody, in fact, it goes a little bit more than that, because in the EDLab chain of custody, sort of a guidance document, because it will also ask you to record the temperature while you are collecting the sample. It also asks you to record the chlorine residual if while you are collecting the sample. These all are the factors which help the laboratory. Of course, beside that, you will find the place to enter the chain, time of collection, who is collecting the sample, the facility where it is being collected, what is the location, what is the test site. So it's a very comprehensive. Why don't you try, like, actually, if somebody wants, we can of course supply our chain of custody to them, and that sort of like guidance document for them. It's very helpful while you are collecting the sample, not only for testing purposes but reporting purposes also, because that if you don't put the right information, then your report is also not going to identify afterward, and you will be start scratching your head, hey, whether I collect this sample from the room 302 or it was 301, because you will afterward you will forget. But if it is chain of custody, you will be exactly knowing that it is collected from 301, and where 301 is located in our west wing building or it is located in the north wing building. You can also find out that whether, and then location, whether it is my Tampa location or it is my California location, you can also distinguish. So it is very worth document to see the environmental laboratory chain of custody.
Excellent. And then that brings us to our last way to collect samples, and that's to be able to collect air samples.
Yes, the air sample is many time I've been asked in conferences, seminar, etc., that frequency of Legionella or chances of Legionella getting an air sample, how fair it is. Well, in my experience and my expertise, that's not very frequent. Let it be very clear. But if it is in the air, that is more dangerous than having in water. So it is quite obvious that you need to find the information whether Legionella in the water or in the air or not. And typically the place where you have a lot of water misting, etc., especially in the hot summer days, like a lot of museum park and etc., then that is worth to take this sample, because you are misting, and if the water is contaminated with the Legionella, can you believe that all the sports are going to be airborne, and it is very easy to get the exposure if or should you have that kind of air or contaminated air around you. So that kind of avoid. Real quickly, I want to tell you that how to collect the sample. These samples are known as bioaerosol, and it is being collected with the help of an impactor, and basically N6 impactor developed by the Ederson is still a good way to collect that. You can use like a flow rate 23.1 liter, and at least you have to collect the sample for 10 minutes. As I said, the prevalence of Legionella in air is not that great, so you have to take a little longer sample so you can sample more air. And in order to do that, you have to have a specified type of media if you are hunting for Legionella. Though Legionella can grow also on the TSA, you can do the sampling, but it is really recommended BCYE, buffer charcoal yeast agar extract. It's a mouthful of word, I don't want to tell you even, but that's a specialty media on which you can get the Legionella, and then you uniquely identify each and every sample so that you can delineate on the report and fill again the chain of custody. That's the magic word, chain of custody, record, documentation. These are the word I always say you a million times, like record, whatever you are doing, so that you can find out later. And it's very easy, believe me, I have dealt with thousands of sample. It's very easy to forget the sample, this place or that place, here or there, that kind of thing, that can avoid the document. So there you go, that is your air sample collection procedure.
Yeah, and I would say that bioaerosol sampling is a pretty sophisticated type of sampling that would typically involve an industrial hygienist or a lab technician or someone that's experienced with this type of equipment, whereas just being able to have a sterilized water bottle and being able to take the water and fill out a chain of custody, or even the swab, I can even do a swab, is fairly easy. But when we talk about air sampling, you're going to have to either have an industrial hygienist on staff or consult with somebody like Pure Air Control Services or EDLab to be able to help you do that type of testing. So the samples are collected, the chain of custody is filled out very precisely, as Dr. Sahay said, and the sample comes back to the lab. And so
And
there's
the lab,
basically
the process,
three main methods to be able to test once these samples come into the lab. And so that's what I'm going to have Dr. Sahay briefly go through right now, is these laboratory testing methods.
yes, and I'm really going to go real quick, but I hope that I'm not going to be too fast so that you can understand that. The Legionella testing typically handle in two different way. First one is the non-culture method, where you don't culture anything, and the second one is the culture method. Well, I'm not being influenced, but the CDC still consider culture method as a gold method. Okay, and then there is a third way of doing it, that is called as molecular method, which is obviously come a part of non-culture method, where Legionella is being not cultured, but we just delineate it because it goes on the molecular level. Well, the non-culture, a very frequent non-culture method, is that the direct percent antibody test, which is DFA, in which you take the sample and look under the microscope with a proper dye, and that dye is fluorescent, so the bacteria kind of glow in the microscope. So many of you know that what a glow in a dark shirt. So it's something like that. It appears under the microscope, and that's what the microbiologists count. The second one is the antigen identification test, in which you have certain chemical, you make the chemical reaction between antigen and antibody, and that's how you report it. The third one is a very rapid test mechanism way, that in which that you can see this lab staff is holding the different kind of wells here, that what we call it, and then we put all these the water collected with certain reagent mix in it, and then afterward it develop a color, and that's how you identify whether it is a positive well or negative well, and that's how you report whether Legionella is there or not. And then in the next slide, I'm going to tell you that the culture method, the main thing is that recovery of the bacteria, meaning the bacteria is the water, and we know that the bacteria is also culturable, but the trick is that how you are going to recover it. So there are a lot of methods by which you can recover the bacteria. One is called as heat enrichment method, other is called as direct plating method, other is called as filtration method, other is called as the acid-based treatment method. So these are the different methods by which you have recovered the bacteria from the water or the source sample, and then afterward you put in the specified the culturing media, that is called as a specialty media, and of course BCYE is one of them, PVC is another one. So these are the media that is being typically used to culture and identify the Legionella. The identification is done with help of an agglutination test, which I said you earlier, that a certain type of antibody is going to react, and then you get as a result that reaction, and it become positive reaction. But the limitation of this test is that it takes a little longer, 10 to 12 days, as you can see, though sometime I have seen in my experience 7 to 8 days the reports are ready, but it's not like a practice. Sometimes you have to really wait enough to make sure the Legionella grow. Now we are going to go on the third method, and that method is the molecular diagnostic method, that is also known as DNA amplification. Many times you understand that what is the PCR. PCR is nothing but it is a technique for the DNA amplification, that is called as polymerase chain reaction. In this particular method, what happens, you take certain number of gene of that particular bacteria, such as Legionella, with a marker, and then you multiply it. For example, you have one gene, and by the time it goes 50, 60 cycle, it is going to have millions of gene, and that millions of gene give you a fingerprinting that particular gene belong to a particular organism only. So based on that fingerprinting technique and molecular diagnostic, you get it, and this kind of result we observe in the laboratory. As you can see that there is certain negative sample and then certain positive sample, and then you run your sample along with the positive and negative. So there is a certain curve you are going to recognize. Based on that, you can see you have a positive sample or negative sample, that how the machine reads. That is a sequencing, what we call in terms of science. So we do the genetic sequencing in order to find out that what kind of bacteria, and we have gone on the molecular level, so we can identify the genus and species both. We make sure that the tests are valid, which can be ascertain by making some negative and positive control, as I said here.
And so this PCR method is actually a very quick method, or at least certainly quicker than 10 to 12 days, right?
Exactly, and that's what I was going to make an observation, that the PCR method is not only accurate method, but most of the time in our experience that if sample turning positive on the PCA, most likely your culture is also going to turn positive. But the beauty of this method is that if you're responding to an emergency kind of situation, such as cluster or epidemic, something is happening somewhere and you really need some guidance that where we go from there, then this test is awesome, because within a day, actually within few hours, we have the test result ready, and based on that the evaluator can make the decision, an informed decision, so that it is not going in a vain. So this is a very useful test, and that's what I said, that it is a little bit of expensive test in comparison to previous two method, but it is worth, because it can save you a lot of dollar in the back end. Now this is the another slide which I wanted to explain real quickly, that when you have the result available from the laboratory, then typically the results are two type. One is qualitative, other is quantitative. Qualitative, obviously you are going to have presence and absence, so it will just going to tell you Legionella is presence or absence. But qualitative is going to tell you is that also that how bad it is in terms of colony forming unit, most probable number of colony per ml, etc. That give additional confidence to the evaluator to find out how bigger the problem is, so that they can make their control measure accordingly. Even in case of there is no standardization on PCR, but PCR can also tell you that how frequently or how green the situation is based on the test result. So those are the genetic test is very important. The culture test is very important, because this is going to be the very confirmatory test, because that's a gold standard, and that's where you for sure find out that what is the species and the genus. Of course, molecular diagnostic get you further, that zero grouping, etc. It can be done with the culture and the PCR with the both method. So that's what your laboratory interpretation, that how you interpret the report.
And in this slide, we see some pictures that are pages out of what would be a report, right? The actual
Yes,
report.
this is this particular one is
for
the
documentation.
PCR report. Yeah, this is the PCR report, this is your culture report, this is your non-culture report. So you have all three kind of report is just for an example to show that is very helpful, and that is going to be a part of document, and that is worth to have on file, so that in case of emergency, you are not going to run pillar to pole, because an informed person make a very informed decision rather going in a panic mode and knee-jerk reaction. Oh, I have Legionella, let's call this company, that company. And then the people there are a lot of ambulance chaser out there. They are waiting for that kind of opportunity, and they are going to hit you with a big bill and etc. But if you are doing with the due diligence, you have all these things on the record, you can certainly make a very wise and informed decision. You can do better management with the same kind of budgeting or funding.
No, that's exactly right. And so that once you have that data, and you know whether you have it or not, and as part of the larger water management program or plan, we need to talk about control measures. And we don't need to spend a lot of time on this, but there's basically two types of actions, and that's a preventative action or preventative maintenance, right? And then corrective actions should Legionella be found, and maybe even found in great quantities. So, our preventative actions, we're looking at just making sure that that water system is maintained, that the water is constantly flowing through it. Preventative actions certainly includes frequently testing for Legionella and other pathogens. So that's the routine checkup. We want to avoid stagnancy of water. I know ASHRAE would have us flush these systems after they've been completely closed down for these many months. But again, if you test that water and you cannot find the presence of Legionella, let's just get it flowing again and avoid maybe that big expense. But we do want to avoid stagnant water. And then, of course, always keeping an eye on the water temperatures. For corrective actions and pure air control services, doesn't really do a lot with the water system. So we're not a water treatment company, although we have some partners that certainly can do that for you. But I mean, most of you as facility managers, engineers, or building owners probably already work with a company that's doing your water treatment. So you're going to want to make sure that they know what they're doing, or that they have a plan in place should Legionella be found, that they're able to treat the infected water with disinfectants, which could be chlorine-based disinfectants, ozonators, things like this, to be able to flush that out and then treat the water to make sure that they can take care of that Legionella problem. And then, of course, another corrective action would be to actually disinfect and restore the equipment by cleaning it, and then perhaps even restoring it with antimicrobial coatings. And so in this picture, we have an example of one of our HVAC New Life projects at a major university here in Florida. And this was one of their cooling towers before and after. So we came in and cleaned the cooling tower top to bottom. Then we were able to remove all of the rust, prime it, and coat it with these antimicrobial coatings that are going to give longer life to this system and then help minimize the spread of these pathogens. So these are just some of the control measures. Obviously, ASHRAE 188 goes into great detail about those, as should your water treatment company that you might be dealing with. So listen, everyone, we thank you for your patience today. I know we got a little bit of a late start, but we're really right on time on the hour right now. We're going to be taking some questions, so please go ahead and type those into the question tray. And I just wanted to reiterate, we've developed here with our building sciences division and EDLab with Dr. Sahay, a 32-page handbook for Legionella, and it goes into the specifications for the inspection, detection, and identification of Legionella within water systems in and around buildings. So this PDF is available in your handout tray here in your go-to meeting or go-to webinar application. You can go there and download it along with the slide deck, or if you want a free printed copy, go ahead and email us or give us a call and say, hey, I want my free Legionella handbook, and we'll send it out to you, no problem. It's a nice little pocket-sized handbook that you can keep right in your desk in your facility management office. So again, on behalf of Dr. Sahay and myself, thank you so much for attending this webinar. Again, we'll be happy to answer any questions. You know, EDLab isn't just about Legionella, although we're fully accredited to test for it. We participate in the CDC Elite program, but we are also a full-service microbiology and aerobiology lab that specializes in all kinds of indoor environmental contaminants and pathogens. And so that could be allergens, bacteria, mold, and even more. We actually do test using that PCR methodology for SARS-CoV-2 in the environment. So we do provide that type of testing as well. And of course, we're experts in mycology or mold. And so we know a thing or two about that topic for sure. And of course, pure air control services. COVID-19 is not our first pandemic. Nor is testing for Legionella. We've been around since 1984 with these three special divisions, the third one being building remediation sciences. And we focus on the health, comfort, and energy efficiency of buildings. And we have since the beginning. All told, 800 million square feet, 15,000 buildings, strong presence in commercial, healthcare, education, government. And of course, all of our technicians and their various disciplines are fully trained and certified with the correct governing bodies and affiliations. We're also a certified minority business enterprise for whatever advantages that might give you. So again, on behalf of myself and Dr. Sahay, thank you very much. We do have a couple of questions here. One is, will certificates be issued for professional development hours? So if you can comment in the survey that is going to come up as soon as we conclude the webinar, there's a section for open comments. Comment that you would like a certificate, that you were here for the presentation. We can issue a certificate, and while we don't directly offer CEUs, we do belong to many different associations like Florida Healthcare Engineering Association, to name one in particular, but we are happy to provide the slide deck or any kind of consultation to your chosen association that you are getting your professional development hours from, to back up not only your attendance, but what we were presenting here today, if that would help you authorize the CEUs as credit for this course. We had another question that's somewhat vague, and that's from Ronald Roja, and I'm not sure if Ronald's on, but he's asking, what about other disinfectants? And he gives the acronym, Doc. He says QUAQ, QUAQs. So I'm really not sure, Ronald, if you're on, if you want to type some clarification into that. I'm not sort of sure. Maybe he's talking about control measures, Dr. Sahay, to take care of Legionella.
Yeah, there is a number of control measures. I'm not sure what actually Ron is talking about, but like, yes, beside chlorination, there is a lot of hallucination. Then there is we can also do ionization. Those are the treatment available for the Legionella. So I'm not exactly sure what he's looking for.
Exactly. Well, Ronald, we'll be happy to reach out to you via email to maybe clarify that question and provide some consultation on that where it exists. So, well, listen, thanks a lot, everybody. I know your time is valuable, and we appreciate you spending it with us to maybe learn a little bit more about this critical topic as we still navigate our way through this pandemic, and how it is that we're going to be able to reopen these buildings safely and by managing the risks. So on behalf of myself and Pure Air Control Services, thank you very much for attending, and stay tuned for our next webinar, which will be in a month. And I do believe that that's going to be on localized or in-room air purification and HEPA air purification devices. Doc, anything to say in conclusion?
All I want to say, thank you very much for this precious hour you have spent with us. And we are environmental microbiology laboratory, so we can always give you some good testing if you need. And if you need to test your environment for environmental COVID-CoV-2, what they call SARS-CoV-2, we are here. We are having a lot of tests going on in the laboratory, so you can take advantage of that. Contact environmental diagnostic laboratories should you need one. And I really thank everyone again for their time this afternoon, and see you around next time. Thank you.
Thank you.